All right, everybody, thanks for joining this What's New in Simcenter 2306 webinar. Let's dive into some of the new features in this webinar. First off, my name is Glenn Andrew. I am the What's New engineer here at Structures.aero. We use Femap every day, and we're pretty excited about some of these updates. All right, so to start off, I'll give a quick background on our company, Structures.aero, and then we'll go through the new functionality and updates. There's a lot going on here, but the highlight, at least as a sneak peek, is that Femap now supports rotodynamics, all sorts of rotodynamic analysis. That's probably why the new picture on for the startup window has pictures of rotors in it. So yeah, we'll go over some Teamcenter integration improvements to geometry imports, talk through some preprocessing improvements, and that's where we'll get into the rotodynamics new support. And then we'll talk through a few meshing improvements, just a few performance improvements. We'll look at some of the analysis and solver support, especially regarding rotodynamics, and then a few post-processing and miscellaneous / API additions. So first about us, we are a team of almost all engineers, 22 I believe at this time, mostly aerospace, mechanical, and engineering science, mechanic degrees. But we have two groups here at SDA, one that focuses on stress analysis, and the more recent one, started up a few years ago, that focuses on design. We work together a lot, sometimes on the same program, which is a big advantage. And we are, at least on the analyst side, we are all experts at Femap, and we use Femap and Astron every day. On the design side, we pretty much have a wide range of experience across multiple CAD platforms. So some recent projects. This is probably a familiar slide if you've tuned in before, but we have experience in space, in the aircraft world, and also with many UAVs, and then also with miscellaneous projects when things crop up time to time. But the highlights of our kind of company history are we were kind of started off working on the composite crew module for the NASC in the 2000s, and then morphed into the Orion heat shield program for the NASC, which then morphed into or led into working on the Orion crew module, and then has kind of blossomed out into all the different things you see here today, like the Roman Space Telescope, Dream Chaser, helping out with New Glenn, a lot of different aircraft. Specifically, the most recent and big project was XB1, helping Boom with that, and then a lot of different UAVs moving into smaller form factors. But we've got a lot of experience and a lot of engineers with different strengths from helping out with different types of analysis with different vehicles. So on the other side of the business, SDA Software is a Siemens value-added reseller. We are sellers and supporters of a wide range of Siemens products. For the most part, it's Femap and Astron, and then also NX. Those are probably our core strengths. But coming along very quickly, we are supporting SimCenter 3D, Star CCM, FiberSim, Solid Edge Heats, and we also train in these softwares. And actually, we do have a Femap class coming up on August 21st through 25th. So if you're interested in that, I think we still have some space. And that should be coming up very quick. But that's a good primer on how to use Femap. And that's taught by the engineers actually who use the software. So it's actually really good stuff. And we also offer advanced training in Femap and FiberSim. So past training, we also offer support. So, you think you found a bug, we can talk through it with you and then report that back to Siemens and help get it fixed. Or maybe, trying to figure out how to use portions of the software, we also help with that. But the key point here is that if we don't know the answer, we have direct contact, especially with Femap, with the Femap developers. So we can get issues identified and resolved much faster than, I think, just supporting a ticket through the Siemens portal. All right, so here's the Femap roadmap. You can see we've come pretty far down the road here for all these different releases. I think they kind of squeeze they've kind of just keep adding on different releases towards the end of this graphic here. But we are on the 06 release, which is partway through this year. I think the main feature releases are the 01s, but it's kind of hard to tell because they've had some, at least this release has some really big stuff in it for Rotodynamics. So, but the next one should be out in January 2024 timeframe. So look out for the What's New webinar around then. All right, so let's dive into some of these updates. First off, we're going to start off with Teamcenter Integration. So I think Teamcenter Integration was introduced in 2301, or if not then, very recently. And I think a small improvement that they're making with this 2306 release is that you can now specify multiple Teamcenter server environments. So, and then you can reorder them, and they're available in a drop-down here, so you can switch between ones nice and easy. So in terms of geometry updates, one of the changes here is Siemens has migrated to the standard PLM XML components, and this means that the translators for geometry files have been updated, and basically they're just keeping abreast of all the new versions of different CAD packages and making sure that Femap can read the new file formats if something does come out. One of the other geometry interface updates is that the old geometry import dialog has been replaced with kind of like a file format agnostic read options. And you can still access the old read options box if you click alternate interface, but it's just it should be more simple if you ever import like two different file types. It should give you the same type of read options for everything now. Obviously, it'll adjust the different options for different file formats, and then you can access the old options via the alternate interface button. So moving on to preprocessing updates. The big new release for this version is the addition of support for Rotodynamics Solution 4.14. And this is a dedicated package of Rotodynamics options. Previous to this release, Femap did not support anything related to Rotodynamics. So this is a big capability upgrade, and it enables Femap to write out all the different cards that Astron has been able to support for some time. So I think the solver is actually SAMSEF, but basically Femap can now formulate and write out the bulk data entries that would be required to run the Astron jobs. So this is a big improvement, and it gives a lot of capability for people who probably might not have had a reason to use Femap in the past. Now Femap can help you out with Rotodynamics in addition to all the other things that it can. So, and the last thing I'll say here is that it does have a tokenable solution, and that's available through Enterprise and Astron. So what actually is Rotodynamics? We here at SDA don't do a ton of Rotodynamics, so I actually had to look it up. And basically decompose what this is actually doing, but essentially in its basic and in the most basic form, it can account for system modal frequencies that change with the speed of rotation of a system. So it can account for things such as Coriolis force, gyroscopic forces, stiffening and softening of the structure as the rotational speed increases or decreases. And then it can also predict resonance, where you can look at like as you ramp up through a certain rotational speed, you might cross some of the fundamental frequencies of different components on your rotor, and by looking at that data, you can predict resonance. And then also you can predict transient response if you wanted to dive deeper and look at actually what happens when you do cross one of your component natural frequencies as you ramp up through a rotational speed. So then you can also look at the steady state response and then account for gyroscopic forces in a linear static analysis. So what does that specifically mean in Femap and Astron? There are 5 new solutions available. There is maneuvers, which is basically a linear static analysis accounting for the rotational forces, i.e. Coriolis, gyroscopic, that type of thing. And then there's also the eigenvalue analysis, which computes the modes of your system, of your rotor system at rest. And then the complex modal analysis is used for finding critical speeds, basically crossings where your rotational speed matches the one of the frequencies of a component on a rotor, such as like a turbine blade or something. And then the harmonic and transient analysis look at the response due to a frequency or a time-dependent excitation. So you'll see they're all added here in the analysis set window. So in order to support the new Rotodynamics solution in Astron, Femap has now the ability to write out new element and property types, and namely these are bearing, gear, and Fourier element types. There's also new entity types in Femap, and that is XY plot definitions for requesting different information pertinent to rotodynamic analysis, bearing speeds, and also rotational speed entities. And then also they've added the ability to define unbalanced mass and unbalanced moment loads for the actual analysis. So this is just an example of what a bearing element property looks like. You can have a bunch of different stiffness and mass terms across this whole matrix. And that's written out as a C-bear and a P-bear2 entry. And then gear elements are also supported, where you can define the module, the number of teeth, the pressure angle, that type of thing on the property card. So in Femap, there are actually 2 ways to get at the rotodynamics entities, and that's either through the, like pretty much universally in Femap, there's 2 ways to access, more than one at least, to access different information. So you can go through either the file structure, model, rotodynamics, XY, bearing, rotational speeds, or you can go through the actual model info tree, and the entities are listed there as well. So you can see here, kind of like there's an error model, simulation entities analysis. There's the new branch called Rotodynamics model, which has the XY plot definitions, bearing speed, and rotational speeds that are used for input into the analysis. One of the interesting things about the XY plot definition is that it allows you to request nodal, elemental, or maybe an more advanced input or output. So there's actually a manager for managing which plots you're actually requesting from Astron. So I felt this was a pretty neat method for maintaining the different requests that you're making from the Rotodynamics solution, and then making sure that it's post-processed into a format that you can use in Femap as well. So here you can see you can request displacement, velocity, acceleration, reaction forces, elliptic orbit parameters for the nodal XY plot definition, and then for the element information, you can request stresses and forces. And then if you have an advanced XY plot definition, there's a lot of different information you can request through the tabs here, such as bearing parameters, mass, damping, and different results. And the XY plots are defined in the info tree or through the model tabs at the top, but then to actually turn them on, you request them in the analysis set manager, similar to how monitor points work, where you can create them in the model, but then you have to request them in the analysis set manager. And that's just so that you can change which plots you turn on and off in different analysis sets. So one of the new entities is a rotational speed card. And this writes out omega 1 or omega 2 bulk data cards. And basically you can define an individual rotation speed or a sweep or a logarithm sweep. And then you can see you can define the first speed and then the increments and number of increments there as well to define the resolution. So the two new load types for rotodynamics is unbalanced mass and unbalanced moment. These are created just very similar if you create a nodal load, but then you scroll down to the bottom and you can pick one of these two. And then you can also assign them to a rotor region and make them a function of speed. All right, moving out of some of the rotodynamics, but we will bounce back to that every once in a while throughout this webinar. We'll talk about some of the meshing improvements coming down the pipe for 2306. And if I didn't mention this already, 2306 is available on the support center of Siemens. So if you haven't already, you can download it and go ahead and upgrade to the newest version. All right, one of the more exciting improvements for me at least in this new update is the meshing improvements to the mesh region. Previously, in previous versions, you had to be very careful about the numbering of your mesh and actually had to renumber to actually bridge this type of boundary, which if you're working in like a big GFEM, the numbering can be very important and you don't want to do that. So this is actually a really big deal because you do not have to renumber to get a good matching mesh across the interface. It is important to note that you do need the same number of elements, so it can't handle like a mismatch, but at least you don't have to renumber, which is really nice. So here's a quick example. If you start with this model that's 4 different sections, it looks like probably just rotated and reflected. You can then join them if you just select the elements on one side and the other, or maybe just all at once, and then it'll zip them up and create new elements to join them together. Again, you have to have the same number of nodes and elements on either side, but not the same numbering, or not aligned numbering, if that makes sense. And then to zip the center up, the same command was just used with the matching nodes and elements. So that's pretty neat. That'll save some time in the future. All right, getting into performance improvements. Continuing on with the unified graphics architecture released in 2301, the Femap development team has continued to work kind of on the back end to be able to improve the performance and allow you to not allow you to not have to switch between like performance graphics and back. So the unified graphics architecture continues to be worked on, and there are updates coming down the pipe. And then also, I'm not sure how often this is totally relevant, but if you have a extremely large model with an extremely large number of properties, basically one property per element, then that could bog Femap down considerably. And the Femap team has basically enabled this to be a thing. And now there's a 6 to 8x improvement in frames per second for the same hardware on this extremely large model. I think this could be actually helpful for models where you're trying to optimize like a massive ISO grid and you have just tons of like basically one property per element, and you're just trying to figure out what thickness you need. This definitely could be helpful in that sense. All right, let's get into some of the analysis and solver support. This will kind of touch back on some of the Rotodynamics improvements. So this is specifically talking about in the analysis set manager. There's a lot of new dialog boxes that pop up when you actually select one of the Rotodynamics solutions at the beginning. So they've added Astron Rotodynamics options, which is this box, a rotor modeling assembly selection, which we'll see, and also a place for, they've changed up what the boundary conditions dialog looks like if you're in a Rotodynamics context. And then like earlier, we talked about how you can define a bunch of XY plot definitions, and then in the analysis set manager, you can select them as well as rotational speeds. So here's the new rotor modeling assembly selection. The big thing to note here is that you can have a maximum of 10 rotors. So that's kind of like the top end of what you can run here. And then here are the rotational speeds and boundary conditions input boxes. You can see here you can select which one. I kind of think of as rotational speed as kind of like what loads am I running in the Rotodynamics analysis. So this is kind of like a loads and boundary conditions slide, but you can pick which loads you want to run with, i.e. speeds. And then also the boundary condition box does look different for a Rotodynamics solution, but this is where you would select like a static or a dynamic boundary conditions, or maybe an unbalanced load, or different multi-harmonics to request or omit. Okay, jumping out of the Rotodynamics, they've also updated some of the interface for Solution 402. They've changed the name of this dialog here to strategy parameters and added kind of like a call out that it's writing out this bulk data card. And then they've also enhanced it to be a little bit more clear and added tabs to kind of keep everything more organized, because there's a lot of inputs for these Solution 401 and 402 solvers. And then they've also added some defaults, which is nice. All right, going into post-processing improvements. One thing to note with this Rotodynamics solution is that it outputs results in the SD5 file format, which is based on the HDF5 file format. I think this is related to like kind of the direction that SimCenter is going. So this is the output file that you'll read in, and I think this is the only file at this time which is written out to SCD5, but that might be coming later on instead of an OP2. All right, so in the SCD5, you'll find two different types of results. There's nodal and elemental results, which we're all familiar with, and those are going to come in as output sets and output vectors, which you can then, if you have complex data, you can view through the complex results options. But then there's also the XY format results. And these are stored as Femap functions, but you can use them through the charting pane or view them through the charting pane. And this is a Campbell diagram, a very common Rotodynamics method for viewing data, and it shows how the different modes of your rotor are changing with rotor speed, basically RPM or sometimes frequency, I think usually RPM. And you can see this blue line here is the rotor speed increasing, and then wherever you cross one of these modes is where you might have an interaction or a coupling or an instability where you might excite one of these modes. So all the crossings are what you're interested in a rotodynamics analysis, or potentially where two different modes cross each other. And as a reminder, they're changing due to the different types of forces involved in a rotodynamics analysis, such as Coriolis, gyroscopic, stiffening or softening of the structure as it spins faster or slower. All right, getting to the end of this webinar, we're going to cover some of the last miscellaneous and API improvements. So in 2301, I think it was 2301, the command finder was vastly improved. And in 2306, it now actually, if you click on one of these options, it'll open up the dialog box and kind of flash it for you. And if it's a command located within a toolbox, that's what it does. But if it's a command located in a pane, it'll just pull the pane up, such as like the data surface editor or the post-processing toolbox. So I thought that was kind of cool. I think NX does something similar, so they're kind of following that direction, but it basically saves you from some time from having to like follow this chain of commands. It'll just pull it right up for you. And then also they've kind of expanded what I kind of think of as like the dictionary for the search tool. So it now knows like other words that are common in other FEA applications. So like grids, that's a common thing, like Astron nomenclature. So it knows that like if you're looking for a grid, you're probably looking for a node. So it pulls up nodes related tools or operations. Okay, so we'll kind of gloss over some of the API improvements. They're basically just anywhere they've extended the GUI Femap functionality, they've also added in API elements to connect in and do the same thing on the API side. So I wouldn't say they've done this for everything across the board, but for the majority of user interface updates, they've connected to that on the back end as well. So like I said, the geometry translator was updated. So they added the geometry interface object, which allows you to call that through the API and access the new functionality there. And then obviously they added a ton of rotodynamics functions and objects and properties that you can then access as well. So in addition, they also added some options to perform actions on the messages pane, which is interesting. Selecting, maybe you could save those to a file if you wanted like a log of what your API is doing. And then also continuing to build out the connection from the API to the GUI with geometry surface ruled commands and mesh control size on surface. And you can also set the transparent logo through the API as well now. All right, before we cover kind of where to find the rest of the what's new information, if you have any questions, now is a good time to start typing those into our question queue. I'll try to answer them as best as I can. But we're wrapping up, so if you have any questions, go ahead and answer that, or go ahead and go ahead and ask. All right, so this What's New presentation is actually fairly trimmed down from everything that Siemens released. So this is kind of something new that I want to point out, where if you are interested in more, and there's a lot more, I would actually highly recommend anyone who's here should probably just scroll through at least the actual PDFs that accompany the Astron or the Femap installation, because there's a lot there, and maybe there might be some caveats that I didn't cover, or something specific to you for your analysis. I try to cover like what I think is going to be helpful for the most number of people, and maybe something that I think would be helpful, highly helpful for me. So if you go into your Femap install directory to the PDF section, there's a What's New PDF, which is a great. They actually go into like explanations about what was improved and why. So I find that nice for preparing for these types of webinars. And then also in the README, they have updates, and they'll list like all the small stuff that they've changed as well. So if there's like this small thing in Femap that's really bugging you, they might have changed that, and you might go look there for that. And this is one example of those. For this version, they've added support for reading and writing layup titles to Astron files. So for example, if you have a DAT file from somebody else and you drag and drop it into Femap, previously all your layups would come in as like untitled. And if you open up the DAT file, you can see the title's right there, it's just commented out. So that was really frustrating. But now they've updated Femap to be able to read those layup titles, which is really nice. Helps keep things more organized and transferring information between people. So there's a lot of stuff like that. And then also in the README, there's corrections. You can go see what bugs were fixed as well. So I like to do that and see if there's anything that might have messed up my analysis in the past, or like learning things to watch out for if I'm ever using an older version of Femap, which has definitely happened, where a company will like pick a certain version and stick with that for a few years. So, and then also, we really didn't cover much of this, but Astron, with every release of Femap, also gets updated, but it's a different development team. But if you go into this directory, it's probably different for some people, just depending on where you installed it. There's this PDF called the Release Guide, and that has a lot of information on what new things Astron can do. This likely isn't supported by Femap, just because the Femap team kind of tends to lag the new capabilities of Astron because they have to build out the interface and functionality. But if you need to go like adjust a bulk data parameter to take advantage of the new Astron functionality, you might be interested in looking through here. I think that's it. We're gonna go ahead and go through some questions now, but if you have any questions that you'd like to talk through or discuss over email, feel free to email me. And if you have any questions about pricing, or you'd like to see a Femap demo, you can contact Keith Brennan, our Director of Sales, through his email or his phone number. So I'm gonna go ahead and look and see if we have any questions. All right, it looks like we do. I'm gonna go ahead and pull these up. So it looks like someone asked, when was Rotodynamics added to Astron? Astron has actually supported Rotodynamics for a while. However, I think the new SAMSEF solver was added sometime around like version 2020. If you go back through the release notes, the solution 414 changes start happening around 2020. So I think that's when they cut in this new solver based on SAMSEF. All right, someone else asked, has the elapsed time bug been fixed in the analysis monitoring pane? I don't know about this bug. I haven't noticed it. But if you go into the, it would probably be the README because that has the corrections. you could Control F and see if you can find something like that. I can actually look into that and see, but I haven't noticed anything. Maybe if you could ask another question and clarify what the bug was, that would be helpful. Oh, okay, someone else commented it remains as 000 until the analysis has been completed. So it's actually not reading the elapsed time in 2301. I would bet that's been fixed, but I will follow up and check. If it was reported, it was definitely fixed. Actually, yeah, I will follow up. Several people asked that question, actually. Nice. So I would bet that's been fixed. And then someone said in version 2022.1, there is a bug in this slice tool. So if you have any bug reports, definitely submit those to us because we're always interested in making the software better. It helps everybody. So feel free to email us if you have a bug report, and it's generally much better to attach like a file and instructions of exactly how to reproduce the bug, or else it's probably not going to get fixed. The Femap developers have a lot on their plate, so it's much better to like basically hand them the bug on a silver platter, and then it'll definitely get fixed. And they actually are like very, very appreciative of that. All right, someone asked, when I import a surface model of box 6 surface, okay, they say they'll send a video of how to recreate the bug. All right, that's all the questions that I have. I'll stay on the line for another minute or two in case anything else comes through. Actually, I will go ahead and look up in the change log if the elapsed time bug has been fixed. So we can go ahead and check the program files, Siemens 2306 PDF README. And let's see. Hey, there we go. Corrected issue which caused the elapsed time field in the analysis monitor pane to not update until the analysis is completed. So this was corrected. So that's good. Yeah, if that many people noticed it, it was definitely reported. But yeah, it's good to ask in case it hasn't been. All right, I don't see any other questions. So if anybody would like to ask further questions, feel free to email me or Keith. And if you want a demo, ask Keith as well. We'd be happy to help you out. Thank you very much and have a nice day.